Hello everyone, welcome back to the channel once again. I'm so glad to have you here with me. So in our last video, we looked at IP addresses, and in this one, we are going to look at a topic that goes hand in hand with IP addresses, which is the concept of subnets or subnetting. So without wasting much time, let's dive right in. Subnetting is simply the art of dividing one large network into smaller logical pieces called subnetworks or subnets for short. So for instance, if it is an organization, instead of having one big network and everyone connecting to it, we can decide to divide this network, give part of it to the finance department, give part of it to, say, the technical team. So that is what subnetting does. We actually divide the network into parts and pieces that are very manageable. So what are some of the importance or the reasons why we actually do subnetting? One main reason is to reduce the broadcast chaos in the network. So in a normal big flat network, devices constantly send out broadcast messages. And if you have the network as one very big network, every device hears every broadcast and it can become very noisy and inefficient. So subnetting creates smaller rooms, limiting the whole broadcast conversation to only devices that need to hear it. Another reason why we may do subnetting is to enhance security and control over the network. And this is very huge and important because with subnets, you can place your corporate service in one subnet, place your guest Wi-Fi in another, and then you have also a different subnet for finance department and other stuff. So by putting routers and firewalls between these subnets, you can create strict rules about who can talk to whom, and a breach in one area is contained so that it doesn't affect the other subnets. That's one very important reason why subnetting is a real-world practice. To read a subnet, there are these 4 key principal labels you must understand. So to explain these terms better, we are going to take the IP 192.168.1.5/24 as our example. The network address or the network ID. This is the name of the subnet itself. It is usually the first address in the range. So in our example, our network ID is going to be 192.168.1.0, and this address can never be assigned to any device. It is the label of the whole subnet. Now, secondly is a broadcast address. This is the address for everyone in the subnet. So a packet sent here is delivered to all devices in the subnet. It is the address at which a device sends a packet to when it wants to communicate to every device on the network. That is why it has the name the broadcast address. It is also never assigned to any device. It is the last address in the subnet. So in our example, the broadcast address is going to be 192.168.1.255, and we would explain how we come about that very shortly. We have the usable host range. These are the actual assignable IP addresses for devices in the network. It is everything between the network and the broadcast address. So from our example, every IP address within 192.168.1.0 and 192.168.1.255 is a usable IP address. Lastly, we have the subnet max. So the subnet max is basically the IP address that describes the network. So from our last video, we learned that the IPv4 addresses is a 32-bit number that is divided into octets, which is made up of 8 bits. Now, without getting into so much calculation, the simplest way we can understand the subnet max is that it divides the network into 2 portions, which is the network portion and the host portion. So the subnet max basically tells us which part of the address is for the network and which part is for the host. The part which is for the host is basically the part that determines the number of host devices that can be connected to the network. The classless inter-domain routing is a compact way to represent IP network and its subnet max. So in our example, 192.168.1.5/24 is our CIDR notation. Now, to understand the CIDR notation, it is very simple. The number after the slash is simply telling us the number of bits that make the network section of the subnet max. That simply means that if we write our subnet subnet mask as a 32-bit number. The first 24 bits are for the network portion. The network portion is always written in ones when we convert it to our binary and write it as octets, and then the host portion is always written in zeros. So for our example, if we want to find the subnet mask of the IP we were given, what we are simply going to do is write the first 24 bits of the 32-bit IP address as ones. So the first 3 octets of the subnet mask is going to be 1. So here, bear with me, we are going to write a lot of ones. So in writing this, we are going to have 1 1 1 1 1 1 1 1, which is the first octet. This is 8, so 9 10 11 12 13 14 15 16, and then we go on 17 18 19 20 21 22 23 24. So now we see the first 24 bits of the address has been written as 1. That is just what the /24 there is telling us. And then as we've written 24 out of a 32-bit IP address, obviously we know we have just 8 bits left, and that 8 bits belongs to the host portion, and they are always written in zeros. So that's just it. We are going to have 8 zeros here. And now what we can derive from this is that the network is going to have 2 raised to the power the number of zeros here devices connected to it. So here we have 1 2 3 4 5 6 7 8 zeros. So 2 raised to the power 8, which is going to give us 256. So that's just it. Our network is going to be able to contain 256 devices, or say 256 IPs. And we know from this that the network address or the network ID cannot be assigned, and the broadcast also cannot be assigned. So we are going to be left with how many? 254 usable IP addresses. So now that you get the concept, you could apply this to any number you see next time. If you see /26, all they are telling you is to write the first 26 bits of the subnet mask as ones, and then you are going to be left with 6 zeros. So 2 raised to the power 6 is going to give you the number of devices the network can contain. So when we go on, we are going to realize that the number after the slash is the size indicator. Bringing it all together, subnetting is how we build structured, secure, and efficient networks by dividing large IP spaces into manageable sub-networks. Thanks very much for watching, and if you found this video helpful, please do well to smash the like button and also share and subscribe if you haven't, and see you in the next one.